Hi guys, let us have a look at this question 2 of the NSC Grade 12 Maths Final Paper of 2023. So the first question we have over here is on this arithmetic sequence, we have to determine the value of T91. So given that it's an arithmetic sequence, we know that it follows the general formula Tn is equal to A plus n minus 1 times D. What we would like to then do is then substitute the values and solve for Tn. So we would like T91. So A is the value of the first term, which is 7, plus 91 minus 1, substituting 91. And finally, in the place we put our common difference, having a look at this term, 12 minus 7 is 5. 17 minus 12 is 5, so our common difference is 5. Typing that into our calculator, we get that T91 is 457. For our second question here, we have to calculate S91. Following the same process of substituting into the formula, we first write out the formula. This time it is the sum of the arithmetic sequence. So using the formula n over 2 times 2a plus n minus 1 times d. Let us substitute. So n is 91 over 2. 2 times our first term is 7 plus 91 minus 1 times our common difference again is 5. Substituting that into the formula and typing it out in our calculator, we get that the sum of the first 91 terms is 21,112. Let us have a look at the final question. So it wants us to solve for n this time when Tn is equal to 517. So using the formula for Tn, we have an minus 1 times d. Tn is 517. A is 7 plus, and this time we are solving for n, which is our unknown, and substituting d. So this is 517 is equal to 5n minus 5. 517 is equal to 5n plus 2. Subtracting 2, 515 is equal to 5n. And finally, n is then when we divide both sides by 5, we get it's 103. Okay. That was the first question in the sequences and series and was on an arithmetic pattern. Let us have a look at the second one. So here we have that the following information is given about a quadratic number pattern, and we have that T1, they tell us it is 3, 2. T2 minus T1, they tell us that that is 9. And T3 minus T2, they tell us that that is 21. So we'd like to complete the pattern. So T1 is 3. We don't know what T2 is, but we know that T2 minus T1 is 9. So the first common difference is 9. We don't know what T3 is, but we do know again that T3 minus T2 is 21. So then taking the first term and adding that difference, we will get T2. So 3 plus 9 is 12. Adding that difference again would be 12 plus 21, which is 33. So that is how we got the next term. So it says show that T5 is 111. So we can complete this pattern. So let us find out what's our first difference. So 21 minus 9 is 12. So our second difference is 12. So here's the row of our first differences. Our second difference is equal and it's 12. So we know to the next second difference, we're going to have to add 12. So the next second difference is 33, which we can add to get our fourth term. So 33 plus 33 is 63. And repeating that, so adding the second difference to our first difference, we get the next first difference, which is 45. And then adding 45 to 66, we get our fifth term, which is 111. Okay, so let us have a look at the next question. So this was for T11. Let's just try 2.2.1. T5 was equal to 33, which was our last term, plus 33, which was the first difference. That was T4 minus T3, plus 45, which was T5 minus T4, which is 111. Okay. Let us have a look at the next one. So 2.2.2 says show that the quadratic general term is Tn is equal to 6n squared minus 9n plus 6. So to get the general term of a quadratic formula, we use the three formulas. 2a is equal to our second difference. We use the formula 3a plus b equals to our first difference. And finally, we use the formula a plus b plus c is equal to our first term. So let's do that. For the first one, we have 2a is equal to our second difference, which is constant in a quadratic pattern. So it's 12. So a is equal to 6. Then we use that value of a and substitute it into the second formula, which is 3a plus b is equal to your first difference. So here's the row of your first differences. The first one is 9. So we have 3 and a was 6 from the previous calculation. Plus b is equal to 9. So that is 18 plus b is equal to 9. So solving for b, we get that it is minus 9. Now we're going to use the last equation. So we get a plus b plus c is equal to your first term. A from that is 6, b was minus 9, and c is what we're solving for, and it should equal our first term, which is 3. So we have minus 3 plus c is equal to 3. So c is equal to 6. So here are our values of a, b, and c, which we will then substitute into the general formula. an squared plus bn plus c, that's the general formula for a quadratic pattern. A was 6. B was negative 9. And C was 6. So then just writing that out, we get that it is 6n squared minus 9n plus 6, which is what we had to show. The key to finding the formula for a quadratic pattern is remembering these. These are not on your formula sheet, and you would need to remember them to calculate A, B, and C, the coefficients of n squared, n, and your constant term in the general formula. Let us have a look at the last question. It says, show that the pattern is increasing for all Tn. So if we didn't calculate the general term correctly, it's fine. We can still use the equation, the formula that they've given us. And to calculate if it's increasing, that's telling us that we are looking at derivatives. And in terms of derivatives, we are looking where the derivative is positive. So let us go ahead and calculate the first derivative. So the first derivative, I'll denote it with a dash, is 2 times 6, which is 12. n minus 9. The constant term falls away. Now, n will always be positive. So n is always positive because this is a sequence in series. So it would mean that that term is always positive. And we are subtracting a number that is, well, not, I mean, n is always positive, but n is always greater than 1 because our first term is t1. So this year, at the lowest value it would ever take is 12. And it's always positive because if you substitute 2 or 3 or 4, then you will get a value greater than 0. Well, in particular, greater than 12. Now, from that, we are always subtracting 9. So then we're always subtracting the same number 9, which means this whole value is always greater or equal to 0. So that means it is always increasing because the derivative evaluated for n greater than 1 is greater or equal to 1 is always positive. So that tells us that it is always increasing. That is this question 2. I hope that you've understood it. If anything is unclear, please go ahead and review the sequences and series section, and we will have a look at the other papers. Thank you for watching. Bye.